Hey, hello everyone. Welcome to Rushi Technologies YouTube channel. If you have not yet subscribed and shared Rushi Technologies YouTube channel, kindly subscribe and share. Today, I am going to discuss about the most very important like deployment strategies or a deployment approach, like what is physical deployment or a traditional deployment, and what is virtualized deployment, and what is a containerized deployment in a detailed way. So here, whether you are a developer, whether you are a DevOps guy, so understanding how we can build and how we can release and maintain the applications is very important. So in the past, I mean to say in early 80s, 90s till 2000, we used to follow a process called traditional deployment or a physical deployment. We have a lot of challenges and problems as well as some advantages also. So what is the challenges or drawbacks that is bringing by the physical deployment or traditional deployment when we are deploying applications directly on a physical host. So later, the concept of virtualization came into the picture in early 2000. We used to build and deploy our applications as a virtualized deployments on virtual machines. So that virtualized deployments also have some pros and cons, right? And later we have started building and deploying our applications as a containers or a containerized deployments. In early 2010-13, the concept of containerization came into the picture. And this understanding the physical or traditional or a virtualized deployments and container deployment concepts is very important when you are working as a DevOps engineer or cloud engineer or site reliability engineer. So sometimes when you are attending the interviews, you may have so many questions comes out of the topics, like the interviewer may directly, instead of directly asking the questions what is what, they may ask you scenario based questions or real time questions. So this video will definitely help you to build a confidence on you to explain the questions in the interviews and also use these concepts in your projects when you are building and applying applications as a containers. So without skipping this entire video, watch this video from beginning to till last second. Definitely you will get so much of information about the traditional model of deploying applications, virtualized deployments and containers, how tools like Docker is helping these containerized deployments, and how tools like Kubernetes will be used here for orchestrating those containers. So without skipping this video, watch the entire video. Thank you. If you have not yet subscribed, kindly share Rushi Technologies YouTube channel and kindly subscribe. Thank you. You can build and deploy your applications as a containers, so that containers carries, that container will carry everything whatever is required, softwares, configurations, its dependencies, and application, so that containers can run anywhere. So far we have not used this containerization concept. So far we have not and built, we didn't build and deployed any application or any softwares as a containers. So we will try to understand first. We'll try to understand first past and present deployment approach. Earlier, how we used to build, how we used to deploy, how we used to manage our applications. First, we'll try to understand so that you can easily understand the concept of containers. So first we'll try to understand past and present deployment, past and present of application deployment approach. In very early days, how we used to build, how we used to release any application or a software. So that can be a web application, that can be a static website, dynamic website. So how we used to build, how we used to deploy, how we used to release, we'll try to understand. So let's say the application team, let's say this application team, as per the requirement, they are going to implement, develop the application code. Let's say application team is nothing but this development team. So what this development team will do, the development team will write the code. The development team will write the code. The development team will write the code and they will commit that code into the SCM repository. Source code management. This is, let's say, this is your SCM repository. That can be any type of application. That can be a static website, that can be a dynamic website or APIs. Development team is going to develop the application and they will commit the code or push the code. They will push the code to the SCM repository, right? So what we used to do, we used to, let's say this is your build server or a CI server, manual or it's automation. Whether you are manually building or automation, whether it's pipeline doing, the concepts remains same. Let's say this is your build server or a continuous integration server. So what you will do, you will get the code from here. You will get the code from here. You are going to clone or pull the latest code, and based on the programmatic language, we used to compile the code, create an application package. You are going to compile the code, create an application package, whatever. Suppose, let's say, this application team is working on one dynamic web application. Let's say they are working on one dynamic web application. Let's say they developed using Java. If they developed using Java, they might have used some kind of a builder tools like Maven or a Gradle. But let's say if they developed a dynamic web application using Python with the Django framework, so there might be a Java, the Python code as well as that UI code. Suppose if they developed that dynamic web application in Java, there will be a UI code and there will be a APIs Java code. Like any programmatic language, that doesn't matter. Let's say, consider they have developed one application using Java. As per that builder tool, they will create a compile the code, run the unit test cases, and do the code quality, code coverage, all these things as per integration. If everything looks good, they are going to create one application package. They are going to create an application package. That application package, let's say this is one package, but it will have only application code package. Let's say this is only a package. Let's consider this is your application package. Like in case of Java, it can be like a jar or where, or if it is other program like a tar, it can be like jar, where, tar, zip, like that. It's a package. Then this application package is going to be pushed to the stored in the artifactory. This will be stored in the artifactories. This is build process. This is a continuous integration process or a build process. Artifactory repositories like Nexus, JFrog, like that. They used to store this application package. They used to push this application package here. This is just a application package. Only like that application code, it will be part of it. This is your build process or a CI process. But the deployment how we used to deploy this application package, how we used to deploy this application package in the past, earlier days. In very early days of software, or in very early days of IT or a software, we used to follow this traditional deployment. We used to follow this traditional deployment. So traditional deployment or a physical deployment, we used to have this physical servers or a bare metal servers. This we have already discussed in AWS session. Physical machines or a bare metal machines, that physical servers. Let's say we used to have these servers, this hardware. Basically, this is our compute hardware. So we used to have a physical servers. We used to call this as a traditional deployment. In order to deploy any application or a process, you need a hardware. This is we used to call this as a traditional deployment or a physical deployment. In very early days of IT or a software, we used to follow this. This is basically the hardware. This is basically the infrastructure, required compute hardware, that can be in on-prem or a cloud, that doesn't matter. This is our compute hardware like CPU, memory, and the storage, etc. CPU, memory is nothing but RAM, storage, a disk. So on top of this physical hardware or physical machine, right, we used to boot a OS. So this hardware don't understand any softwares or human readable language. We used to have a OS, operating system. We used to boot the operating system on top of this hardware. We used to have a OS. This can be Windows OS, this can be Linux OS, this can be Windows or a Linux or a Mac. Because hardware, that compute hardware like processor, that compute hardware like CPU, that processor, nothing they will understand human readable language. They don't know Java, Python, .NET, shell script, nothing. So the hardware, the compute hardware will understand only binary code, zeros and ones. So without this OS, we cannot run any process, nothing we can run on the hardware, right? This hardware requires a OS. In order to deploy or manage any process or applications, we are going to boot a OS on top of the hardware, and then we will deploy that application. Within this operating system, within this OS, there is something called kernel. Within this OS, there is something called kernel. That kernel is like a heart of the operating system. The kernel is going to work as an interpreter. The kernel is going to work as an interpreter or a translator, that is going to translate the human readable code into a machine understandable instructions. So here you are going to boot a OS, but we cannot deploy this application package as is here. So this requires, in order to deploy this, we need to have a required middleware softwares. Suppose this application is developed in Java. Without Java software here, without Java software, we cannot run this. Suppose if this application is developed in Python, you need to have a Python software. Suppose your application is developed in Node.js, you need a Node software. So here, before we used to deploy this application packages here in this hardware, in this operating system, we used to install the required softwares. First we used to install, we used to configure this server. Whether you are manually configuring, whether you are using a configuration management tools, that doesn't matter. Within this OS, we install required middleware softwares, example like Java, Python, Node.js, .NET, Tomcat, JBoss, that softwares. And its configurations means, maybe you may need some user, you may need to create some users, you may need to add that users to some groups, or maybe you may need to create some folders, and you may need to change the permissions for that folders or files. You may need to update some kind of a settings files. So that configuration, you need to install required softwares, and you need to do the required configurations, and you have to set the required environment variables or environment. On top of this, right, you need to install required application softwares, application configurations, and its dependencies, whatever dependencies. Then finally, we used to deploy this package. We used to deploy this application code here. We used to deploy this application code. Let's say this is our application package. Let's say this is our application package. Let's say this is our code. This is our code here. So this is your application package, like a jar, var, tar. So this is how we used to deploy any application or a process. Process is nothing but any program. Any program which is under execution is called as a process. So here the compute, this is our hardware, like compute, CPU, memory, storage. Here we used to have a OS. Within that OS we used to install required softwares configurations. Finally, we used to deploy the applications package here. But here we have some kind of a challenges or a drawbacks that I have already explained. Here. What are the challenges or a drawbacks here? Let's say this is your compute capacity. This is your system capacity. Let's say you have a hardware. You have a system with let's say 16 core CPU. Let's say you have a 64 GB memory, that is a RAM. Let's say this is your system capacity or hardware capacity. Within this you have configured some OS and you have installed some application. Let's say this application, let's say this application, let's say this application, let's say this is using, this application is using, let's say this is using, let's say the this application is hardly using, let's say this is using just whatever application we have deployed here, this is hardly using maybe 2 CPU, and it is just using maybe 4 GB memory, that is RAM. So this is using, the capacity of the system is this, but this is using only this much. Here our hardware resources, our system resources are wasted here. Our hardware resources or system resources are wasted here. As I already said in the previous session, as I already said in the previous sessions, why we have to waste our resources, sir? Why can't we deploy multiple applications or a process? Can't we deploy so many applications in a single system, in a single OS? It is possible, but you have to isolate, each application from other application. You have to isolate each process or each application. You have to isolate within that OS, within that kernel. If you are isolating each application process with other application process, you can deploy. But here I will tell you. So within this OS, there is something called kernel. In that kernel we have some kind of a concepts like a namespaces and C groups, namespaces and C groups in the kernel. So we have something called namespaces and C groups, kernel, namespaces and C groups. Basically, here, here namespaces and C groups, there is a concept called namespaces and C groups in the kernel. So basically, In that within that kernel we have some kind of a spaces like user space, process space, network space, mount means a storage space, like that. So within that kernel there is something called within that kernel there is something called process area, storage area, network area, like that. We have some concepts. We have some concept called process area, network area, that namespaces. So namespaces in the Linux is like a feature of a kernel that enables separations or isolations of a resources running in that OS. Basically, there is a concept called namespaces and a C groups in the kernel. We have separate namespaces like user space or user area, process space. Mount means a storage space, storage area, user space, process space, storage space, network space. Like that, we have a Kubernetes namespace concept is different. I am talking about this kernel namespaces. Within that OS, we have a process space, network space, storage space, like that. And we have something called C groups, control groups. Using these control groups, we can control the hardware resources to any process like a CPU, memory, you can control. So here, within that OS, within that kernel, we have a user area, process area, network area, storage area, like that. If all the applications, if all the applications deployed in that OS is sharing the same process space, network space, user space, storage space, if any application if any application is causing the issue within that linux I mean to say within that kernel. So if any application or a process causing the issue within that kernel user area or a process area or a network area or a storage area, so if you deploy multiple applications here, let's say you have deployed multiple applications with required softwares and configurations here, if you are not able to isolate each application from other application, if this application is crossing some issue in this user space, process space, network space in this kernel, and other application also sharing the same user area, process area, network area, it is going to impact one process causing the issue in that kernel. Whatever other applications or a process are sharing the same process space, network space, user space, that is also going to be impacted. So if you are not isolating, then you cannot deploy. Even though you deploy, right, even though you deploy, it is going to cause the issue. One process creating a problem, other process or applications will also impact because they are sharing the same process area, network area, storage area, like that in that kernel. So this is where later the concept of virtualized deployment came into the picture. This is where the concept of virtualization or a virtualized deployment came into picture. Here in early 2000, we the concept of virtualization came into the picture. So here again same, this is your physical server or a bare metal server. Let's say this is your physical server or a bare metal server. This is your hardware. This is your hardware, physical server or a bare metal server. Here with the help of hypervisors, we used to have something called hypervisor. Here with the help of hypervisors, with the help of hypervisor, you are creating a virtual machines on top of the physical machines. Let's say using this hypervisor, you are going to create a virtual machines. You are creating a virtual machine on top of the physical machine. Let's say you are creating a virtual machine on top of the physical machine. So while creating a virtual machine, you are creating a virtual machine. So while creating a virtual machine on top of this physical machine, right? You can We can allocate the hardware resources for this virtual machine from that physical machine. Let's say this is the capacity of your physical server. Let's say this is the capacity of your system, your server. right? While creating a virtual machines on top of this physical machine or a bare metal machine, you can allocate the hardware resources for each virtual machine. For this one, while creating, you can say maybe 4 CPU, 8 GB RAM. You can allocate the hardware resources. Here, in each virtual machine, you can have a OS. Here, in each virtual machine, you can have a OS. In each virtual machine, here you can have a in each virtual machine you can have a OS. Let's say you can have a OS with whatever, maybe Linux, Windows, and again you can have a required softwares and configurations here in each virtual machine. You can have a required softwares and configurations, and you can deploy or run whatever application or a process. So this is your virtual machine. So in this virtual machine, you can have your own. Each virtual machine has its own OS, softwares, configurations for that application, and still you have some hardware. So this is the capacity of your physical server. This is the capacity of your physical server, right? Now you can still create a few more virtual machines. Out of 16 core CPU, only 4 CPUs I have allocated for this machine. Still you have a 12 CPU. Out of 64 GB memory available in this physical machine or a host machine, we just allocated for this 8 GB. Still you have a 56 GB. So like this, you can create a few more virtual machines. Like this, you can create a few more virtual machine. Let's say this is another virtual machine. As per the requirement of the software you wanted to run, for this one maybe you might have allocated 4 CPU or maybe 16 GB memory, that is 16 GB memory RAM. This is one more virtual machine. This will have its own operating system. So in that OS you can install required softwares. Like this, still you have a capacity. Then you create a one more virtual machine. This is another virtual machine. Here, based on the requirement of the application or software you wanted to run, maybe for this one, you have allocated, let's say, let's say, for this you have allocated 6 CPU and let's say 32 GB RAM. And still you have some CPU and memory. So total 16 CPU. Out of 16 you have allocated 14 CPUs, and out of 56 GB RAM you have allocated only 56 out of 64. Still you have some CPU and memory. You can create a one more virtual machine or a two more virtual machines, or you can create one more virtual machine, and you can allocate for this one remaining whatever is available. Like this, based on the capacity of your physical machine, based on the capacity of your physical machine, you can create as many virtual machines as possible based on the capacity of your physical hardware, that physical host or a physical machine or a bare metal machine. And in each virtual machine you have its own OS, and within that OS you can install required softwares and configurations and apply. So what is the advantage with this approach? We already discussed. This is called as a virtualized deployment or a virtualization. Virtualized deployment or a virtualization. This is called as a virtualization or virtualized deployment. So in early 2000, this concept of virtualization came into the picture. So we used to build and deploy our applications in the virtual machines created on top of the physical machines. So here, what is the advantage, guys? with this approach, which we have already discussed in AWS. When I was explaining AWS classes, we discussed about this virtual machines, virtualization. What is the advantage? We are using our hardware resources more efficiently. There is no resource wastage here. Our hardware resource, our compute resources are used efficiently by creating a virtual machines on top of the physical machines or a physical hardware. You are utilizing your hardware resources more efficiently. There is no resource wastage. There is no resource wastage. And again, each virtual machine has its own OS. Suppose the application or a process, suppose the application or a process deployed here, suppose this is causing some issue in this OS, in this kernel. Suppose the application deployed in one virtual machine causing the issue here, is it going to impact the applications or a process running in another virtual machine in another OS here? So application causing in this VM, application running in this VM is causing some issue in that user space, process space, network space in this OS. Is it going to impact the other applications running in another OS? Here, no. So here we are isolating each applications from another application into a different OS again. But here using these hypervisors, you are doing a hardware level isolation. Using these hypervisors, we are doing a hardware level isolation. We are doing a hardware level isolation. This virtualization is doing the hardware isolation. Our hardware, this compute hardware, this hardware is isolated using that hypervisors. We are isolating our hardware here using hypervisors. These hypervisors are doing a hardware isolation. This compute hardware is isolated, hardware level isolation here. This virtualization is doing a hardware isolation. And as I already said, there are two types of hypervisors, guys. We already discussed in AWS, and again we are discussing the same because containers is extensions to this again. So here there are two types of hypervisors. What are those? We already discussed. We have two types of hypervisors, type 1 and type 2. Type 1 hypervisors, type 2 hypervisors. So type 1 hypervisor is what type of hypervisor? It's a hardware hypervisor. That hardware itself comes with hypervisor capabilities. That hardware itself comes with specialized operating systems to create a virtual machines. The hardware hypervisors, the type 1 example for type 1, right? Example for type 1, we already discussed Dell servers, IBM servers, Citrix Gen servers, VMware ESXi servers. That hardware. There is a something called type 2 hypervisors. Type 2, type 2 hypervisors are a software based hypervisors. So here in case of type 2, we need again OS here. Again we need an operating system here in case if you are using a type 2 hypervisor. Suppose you are using a type 2 hypervisor, again you need a OS here, operating system is required. This is called as a host operating system. This is called as a host operating system. This is called as a guest operating system. So here also you need a operating system on that physical host, physical server. Example for this type 2 hypervisor, software based hypervisors also we have discussed, like Oracle VirtualBox, VMware Fusion, or VMware Workstation. Suppose within your Windows OS, Windows laptops or a desktop, within your Windows OS also, within your Windows operating system, within your laptop or a desktop Windows, you can install type 2 hypervisors in Windows, like Oracle VirtualBox, VMware Workstation. Using that, you can create a virtual machines within your Windows systems, Windows laptops or desktop also. That is type 2. But this is nothing to do with the cloud or on-prem, guys. this virtualization, physical machines or a bare metal machines or virtualization, this is nothing to do with on-prem or cloud. Okay, whether you are using your own data center, on-premise data center, or whether you are using a cloud environments, cloud infrastructure like AWS, Azure, or GCP, this concept is there: physical machines, virtual machines. But here, whether you are using a cloud like AWS, whether you are using a cloud like Azure or on-prem data centers, also we have the same concept. So whether you are using AWS or Azure or GCP, or whether you are using your own cloud environment, the what type of hypervisors are used? Type 2 or type 1? The type 1. The type 1 hypervisors, hardware based hypervisors. That hardware based hypervisors. That hardware based hypervisors will be used. That hardware based hypervisors are used. But the difference between cloud and on-prem is, in case of on-premise environment, who is responsible for purchasing this required compute hardware? Who is responsible for managing this hardware, and who is responsible for managing cooling system, power supply, and the engineers who can manage the data centers, that ourselves as an organization. But if we are using cloud like AWS or Azure or GCP, so we no need to manage this hardware, we no need to worry about the managing the compute hardware, storage hardware, network hardware. We no need to worry about the data centers, cloud, cooling system, power supply. That will be taken care by the third party companies. That is going to be taken care by the third party companies, third party service providers like AWS, Azure, GCP. But in on-prem also we have this virtualization concept, and cloud also same. So AWS also using a type 1 hypervisor, they are using Citrix Zen. They are using Citrix Zen hypervisors or AWS Nitro hypervisors. They are using two type. That EC2 instance, that EC2 instance is also a virtual machine. That EC2 instance is also a virtual machine, but created on top of the physical machines owned and managed by AWS. So far, you have deployed so many applications. You have taken Java based application, Python based, Node.js based application, you have built and deployed. So we deployed so far in a virtualization or a virtualized deployment only. So what we have done, whether you are manually doing, whenever there is a change in the code, the developer develop the code, they will commit the code to the SCM. Later, whether it's a manual or automation, you got the code, run, compile the code, run the unit test cases, check the code quality, code coverage. If everything looks good, you created an application package, and this you committed to the Artifactory. Then you have taken this package and deployed. But what you have done, you created a EC2 instance. That EC2 instance is nothing but one virtual machine. While creating a virtual machine, you have selected a Red Hat OS, Ubuntu OS, or Windows like that. But within that system, within that machine, you have installed softwares. Did you guys install software like Java, Tomcat, and configured the Tomcat settings before you download or copy this WAR file to there? Suppose you have deployed Node.js application also. Did you guys configure that server with required softwares like Node.js, and did you download the Node.js dependencies and copy that code and run the code? Yes. So this is what you have done so far, virtualized deployments only. Whether you are doing manually, whether via pipelines, you have done the same. But there are some challenges with this virtualized deployment also. That is where these containers came into the picture. That is where this containerized deployments came into the picture. That is where this containerized deployments came into the picture. Here we have some kind of a challenges or a drawbacks also. So I will tell you, but before I tell you what are the challenges or a drawbacks with this virtualized deployment, Do anyone can guess? What do you think? What are the challenges or problems with this virtualized deployment also? Anyone? Just guess. Here we have some challenges. We have some drawbacks. Virtual machines are heavyweight. One problem here, virtual machines are heavyweight. What do you mean by heavyweight? Each virtual machine has its own OS. Each virtual machine has its own OS. That OS itself will consume lot of resources. Resources means that hardware resources like CPU, memory, storage, in order to boot the OS. In order to boot the OS, right? OS itself will consume some CPU, some memory, some storage, whatever we have allocated to that. So virtual machines are heavyweight. Heavyweight means each virtual machine has its own OS, right? In each and every system there is a OS, right? In each and every virtual machine there is a OS. Virtual machines are heavyweight. Heavyweight means that virtual machine, that OS itself will take some CPU and memory, and whatever is available after the OS is using, that can be used for our applications deployed there. And virtual machines are slow. What do you mean by slow? Suppose I wanted to deploy a new application. Let's say I wanted to deploy a new application, or I wanted to scale existing application. I wanted to deploy a new application, or I wanted to scale. Scale means replication. So, in order to first deploy any application, if you are doing this virtualized deployment, first do I need to create a VM? First, we need to create a virtual machine. Creating a VM, and again booting the OS here. After that, you have to install required softwares and configurations. Then only you can deploy your application. So application, this virtualization, I might say virtualized deployments are slow. I'm saying virtualized deployments are slow. Virtual machines is slow means not machines. Virtualized deployments are slow. If you are deploying in this approach, suppose you wanted to deploy or you wanted to scale. Let's say you have only one replica. There is so much traffic coming to this, you wanted to replicate one more. So first you have to create a VM. The process follows like this. First you need to create a virtual machine. First you have to create a virtual machine. Then you have to boot the OS. Can boot the OS. Creating a virtual machine, booting the OS, that starting the system also will take some time. Then you have to install required softwares and configurations there. Finally, deploy your application here. So virtualized deployments are virtual machines are slow. What I am saying, virtualized deployments are slow because you need to create a VM. It will take some time. Boot the OS take time, and again install the required softwares and configurations take the time. Then deploy that application package takes time. So virtual machines are heavyweight. Virtual machines are heavyweight, and virtualized deployments are slow. Virtualized deployments are slow. Slow means the typical process follows this: create VM. First, create a virtual machine. Then, while creating a VM, you are going to configure that virtual machine with some OS. That can be Windows. Booting the OS will take some time. And again, install required softwares and configuration. Time. Deploy the code takes time. So, virtualized deployments are slow. And each and every virtual machine has its own OS. So, virtual machines are heavyweight. Virtualized deployments are slow. Understand what I'm trying to say? Virtualized deployments are slow and virtual machines are heavyweight. And again, maintenance also, guys. Maintenance means suppose you have to do some kind of a version upgrades. OS, let's say you are using Red Hat 8.9, just to give an example. So now all these systems have Red Hat 8.0, Red Hat 8.0. Now you wanted to do upgrade your OS versions, or you may wanted to do some kind of a OS patches. So here, this also you have to upgrade, this also you have to upgrade, this also you have to upgrade, maintenance also there. And again, if you are using enterprise OS, suppose if you are using enterprise OS, licenses also, licenses again, licenses also, licensed cost, maintenance cost, right? And again, virtualized deployments are slow, virtual machines are heavyweight. And again, if you are doing this way, maybe you may see this type of issues also. The applications deployed in one environment may not work, the same application deployed in another environment, another server. Let's say this is your dev server. For production environment, you have created some virtual machines. Let's say this is your production server. Let's say this is your production server. So here you have installed, say, you have installed some, here you have installed OS, you have installed configurations and deployed your application. Maybe the application deployed in dev server or a dev environment working fine, but the same application deployed in a production, it is not working. So you may see these type of inconsistencies. Application works fine in one environment, the same application may not work in another environment. These type of issues also you may observe so many times. It is very common problem. It is very common problem between the developers and testers. Suppose you are already in IT. Suppose you are already in IT, or a, whether you are a developer, whether you are a tester, you might have observed these type of environment inconsistencies. Suppose it is very common fight between the team, application team and testing team. So the application team developed the application. Let's say what they will do, this developer develop the application. First they will verify locally also. Locally means local system also they will verify. Local laptop or a desktop, let's say this is local system, the developer system. Maybe he will have some OS here, Windows or Mac. Most of the time, developers will have a Windows or MacBooks. Very rare Linux desktops will be used. And what that they will do, they will build and deploy locally also, guys. The development team, the developers will internally first test in a local system also. So they will build, they will deploy first locally. Once they feel that it is working fine, right? Then what they will do, they will commit that code. They will commit the code to the SCM. Then we will deploy that application in a dev servers like that. And the developer tested locally also working fine, and he has committed the code, build that code, and deployed that code in a dev environment, dev servers. And the developers are tested in dev servers also, it is working fine. But the same application, let's say that is promoted to the QA environment, quality assurance testing, and that QA environment. The QA team, the testing team is trying to test the application as per the test cases, as per the requirement. And they may feel, they see that some functionalities are not working, something is not working as expected. But when the raise the tickets, or when they come up to the development team, so they'll say, hey man, that application is not working in QA. But what you will say, I don't know. I have deployed locally and it is working fine. And I have deployed in dev servers also, it is working fine. I don't know why it is not working in QA or staging. Come, come, I will show you. Right? This is the dev URL, it is working. This is my local laptop, it is working. I don't know why it is not working here. These type of fights or conflicts will happen. So what do you think? What could be the possible reasons for environment inconsistencies? What do you think here? What do you think? What could be the possible reasons for that environment inconsistencies, environment to environment inconsistencies? Application works fine in one environment, the same application may not work in another environment. Another environment means another system, another server. It might be due to the different versions, that dependencies, that configurations. OS, most of the time there are only two types of OS, guys. Linux, within that Linux, that can be anything, Linux and Windows. So OS, very rare. Because of OS, it may not, very rare, the inconsistencies will happen. The more problems comes in this, the software versions, configurations and environment. Suppose your application is developed in Java. That application team is using some features which is introduced in Java 11. Let's say they developed the code using some features introduced in Java 11. The required version of the software is Java 11, let's say, but here they have installed Java 10. In QA server, let's say we have a Java 10, but here Java 11 required. So in that case also it will not work. Not only softwares, like configuration settings. Let's say that application requires to be executed as some user. Maybe in this system the users are created, the required permissions are granted, but here maybe the user may not exist, or that permissions not granted, or maybe some settings has not been updated properly. Then again, that works here, it may not work here. And environment, environment variables, that application is referring some environment variables, that environment has not been set here. So because of the misconfigurations, I can say misconfigurations, because of the misconfigurations, that required softwares or configurations are not has been done properly. So maybe that same package may work in one server, another server it will not work. But you can overcome this challenge also. How? Instead of manually doing your configurations, you can do a configurations also as a code. Maybe you can write a playbooks, ansible playbooks. You can use a configuration management tool. Same playbook you can execute against a dev server and production server also. You can avoid that manual configurations. You can avoid that human errors. So you can use a configuration management tools like ansible. If you have to, again you have to configure so many servers here, but okay, you can use configuration management tools like ansible for doing a configurations as a code. Otherwise you can build a machine images. You can build your own machine images. I told, right? Machine images like a package. The machine image like a package with the OS also, with the complete OS, softwares and configuration, AMIs in case of cloud like AWS. And using that AMI you can create a dev server, production servers also, fine. But still the main problem will be there. The main problem is virtual machines are heavyweight. Each virtual machine has its own OS, and virtual machines are, I mean to say, virtualized deployments are slow, scaling, deploying slow. So you still have these challenges here. So this is where next level of isolation came. This is where next level of isolation came. We are bringing isolation to the one more level above. OS level isolation. This hypervisors are doing a hardware level isolation. So here isolation brings to the next level now. So here, in the same system, in a same OS, we can run multiple applications, or a multiple softwares or applications in a same system, using this containerization softwares. Here within this OS, using this containerization runtime, there is something called container runtime or containerization software tools like Docker, Rock, Podman. You are using some kind of a containerization tools like Rocket, Podman, Docker, Rocket, Podman. You are using some tools like containerization tools like Docker. Here, in the same system, in a same OS, you can run multiple applications as a containers again. Multiple applications as a containers. But here, sir, last time you said there is something called here in this OS, in this OS, you said there is something called kernel. In this kernel you have a user area, process area, network area, storage area, like that. So if we are not able to isolate, if you are not able to isolate each application, if you are not able to isolate each application from other application in that process space, network space, storage space, if one application is causing the issue in that OS, in that kernel process space or a network space or a storage space, other application are also going to be impacted, like that you said. But now how you can deploy multiple applications in the same OS without impacting each other? So this containerization softwares like a Docker or whatever it is, they are doing the process level isolation within that OS, within that kernel. They are doing a process level isolation. This containerization softwares are doing a process level isolation or a OS ISO within that OS isolation. We are bringing isolation to the OS level, software level. This is doing OS, software level isolation. Here, this containerization runtime, softwares, what they are going to do? So they are going to make sure each process, or each application is isolated from other process or other application within that OS by creating a separate. They are going to make sure this containerization softwares will make sure each container or each application deployed as a container is nothing but a process only. So it is going to make sure each process is isolated from other process within that OS by creating in a separate process space. So this application deployed as a container, this is like a container 1. This is container 2. Container is nothing but a process, guys. So process. So this container process is isolated from another container process within that OS by that container runtime. They will create a separate process space. That softwares like a Docker will create a separate process area, storage area, network area, user area for each container. So within this OS, within this kernel, they are isolating. They are making sure this process is created in a separate process space, network space, storage space, and this is created in a separate process space, network space, storage space, like a separate room. You can think of this system, this virtual machine, as a home. You can think of this as a home, and this containerization software is like making separate spaces, separate room. This containerization software like a Docker, they are giving a separate room for each application, separate space. So if something goes wrong within this space, it is not going to impact other space, other one. I mean to say, this containerization softwares like a Docker, they are leveraging that kernel features. They are using the kernel features for isolation. So this containerization softwares are using the kernel features like a namespaces, so that in each and every container deployed in the same system is isolated from other application in the same system in a separate process space, network space, storage space. So even though one application deployed as a container is causing the issues in that process space, network space, it is not going to impact the other applications even though it is deployed in the same OS, but in a separate process area, network area, storage area. Like isolation, guys, you are isolating each application from other application within that OS. That isolation is taken care by, that isolations are taken care by that containerization software. So we are bringing the containerization one more level above, right? So this is how it work. Let's say you are bringing one more level isolation. Let's say this is your machine. This can be a physical machine or a bare metal machine, that doesn't matter. So this is your physical machine or a virtual machine. This can be a physical machine or a virtual machine, that doesn't matter. That comes with some CPU, memory, storage. And here you have a OS. Here you have a OS, operating system. This is your physical machine or a virtual machine with some CPU, memory, storage given, and this is your OS, operating system. let's say this is the OS operating system. Maybe let me give different color. Let's say this is a, let me give, maybe this is a operating system, that can be window. Here we are not directly installing that softwares and applications in that OS directly. We are having some software called containerization runtime, container runtime. So we have container runtimes like a container D. Docker is also internally using container D. Docker is also internally using container D. We have a containerization softwares. Basically, Docker is also internally using container D. You can use container D or core OS or a CRIO, like that. Basically, whether you are using Docker, whether you are using Podman, internally they are using some container runtimes. So for now, I don't want to confuse you. Let's imagine here you have a containerization software like Docker. Containerization software like Docker. You are going to install containerization software like Docker, or you can use Podman. And here, with the help of this containerization runtime, you can deploy your applications as a containers here. So here you are going to deploy your applications as a containers. That container contains everything whatever is required, like required application softwares configurations. This is container one. Similarly, in the same system, same machine, this can be a physical machine or a virtual machine, in a same machine, in a same OS, you can deploy multiple applications also as a containers. Like this is another container, this is one more container. Like this, you can keep on deploy multiple containers in a same system. You can keep on deploy multiple applications as a containers. That container contains everything whatever is required for that application. Like this, here you are bringing isolation to the one more level above. OS level isolation within the same OS, within the same operating system. You are deploying multiple softwares, multiple applications here, and so many advantages are there here. So many advantages are there. So within the same OS also, you can run multiple different versions of the Java, and combinations also, guys. Let's say within the, suppose you are using this virtualized deployment, maybe you are not isolating, because you are, there is no one is isolating, and you cannot install two softwares, two applications, two softwares of same type. Maybe you need to have a Tomcat 10 and a Tomcat 8 also in the same OS. But there is no isolation here in that OS, in that kernel. There is no, you are not isolating the process space, network space. So within that, you may not able to have a Tomcat 10 or a Tomcat 8 also, like that, for two different applications. But here there is an isolation. Each container is isolated from other container, even though it is deployed in the same OS, because each and every container will be created and managed by that container runtime in a separate process space, network space in this OS, in this kernel. So this will be created and managed in a separate process space or a network space within this OS, within that kernel. This is going to be in a separate process area, network area, it will be there. This will make sure this containerization softwares or a containerization runtime, it will make sure this is created in a separate process space, separate network space, separate storage space in that OS, in that kernel. Same way, so this is also created in a separate process space, user space. This is created in a separate process space, user space. Even though they are running in a same OS, but they will be having their own process area, network area, user area, storage area, and there is no issues. Suppose something, the application deployed as a container in this OS, it is causing some issues in that process area, network area, storage area. It is not going to impact the same other applications deployed in the same OS, because it will be running in its own process space, network space, like that. So isolation is taken care by this container runtime. So the advantages with this one, so many advantages. So containers are lightweight. Containers will not consume so much CPU, so much memory. Why? Why they will not consume so much CPU, so much memory? Because do you think each and every container will have a OS? They don't have a OS. For all the containers are using the host machine OS, the host machine kernel. Host machine means on whatever machine you are hosting your containers, on whatever machine you are deploying your applications as a containers, that is called as a Docker host or a Docker host or a Docker daemon. So this container, all the containers are using the host machine OS, that host machine kernel. So containers will not have a complete OS. Containers will not have a OS, but they will have a OS libraries to interact with the kernel. OS is different, libraries is different. So this container will have some kind of a binaries, OS binaries to work with this OS kernel. So containers will not have a complete OS. Containers will not have a complete OS. Containers is going to, what is common, sometimes in the interviews also they'll ask this question, what is common for all the containers that is running in one Docker host or a Docker system? So common, all these containers are going to use this host machine OS and host machine resources means this is CPU, memory, storage. All these containers are going to share. This is common, your system resources, your hardware resources, and this OS is common for all the containers. So this will also use this OS kernel, and this will also use the CPU and memory, whatever is there for this system. And it can use how much it is required, and this can use how much it is required, this can use how much it is required. So based on the load or a demand, they can consume. If required, you can set the limits also. For containers also, you can set the limits, guys. So even though your system has so much CPU, so much memory, you can set the limits while creating a container process. Whatever application or a process running in this, you can say, even though you have a system with 16 core CPU, you can say this container should not allowed to take more than 2 CPU. It is not allowed to take more than 1 GB, like that. You can set the limits, resource limits. So while creating a containers also, you can set the resource limits. So the C group, there is something called C groups, right? That control group, that C groups in this OS, they will control the hardware resources. If this container is trying to use more than 2 CPUs, it will not allow. If it is trying to use more than 1 GB memory from this system, it will not allow, that C group. So in case of memory, if it is trying to consume more memory than whatever limit it is set, OOM killed. This process will be stopped, the process will be killed, so that application is down. But it is not going to allow to use more than this CPU. In that case, that process will run, that container will run, but a slow response, like that. So you can, what is common for all the containers which is running in a same system, basically the host machine OS or a kernel, and this hardware resources, that is common. Containers are lightweight because they don't have a OS. They are going to use the host machine OS or a host machine kernel. And containers are fast. Containerized deployments are fast. So how containerized deployments are fast here? How containerized deployments are fast here? I no need to create a completely new VM. Suppose I already have a server. In this server, still so much CPU, so much memory is there. In this system, this is the capacity of my system, virtual machine or a physical machine, that doesn't matter. Here I have deployed only 5 containers, let's say. All these containers are just using maybe 10 GB memory, or maybe 5 CPUs. Still I have so much CPU, so much memory here in this machine. Can I quickly create a container? I no need to create a VM here, understand? I no need to create a VM here. So I no need to boot the OS. I already have a system with enough CPU, enough memory. I already have a OS. Can I quickly deploy another application also as a container? Container deployments are fast. You can quickly deploy new container, and you can, if required, you can scale also. Scale means you wanted to increase the number of replicas, so you no need to create a VM. Already you have a VM. Let's say you have so much CPU, so much memory. Still, can I quickly release my applications as a containers? Can I quickly scale? Deploying and scaling also, can I do fast? Yes. Understand what I'm trying to say? Containerized deployments are fast. How it is fast? Because you just need to create a container, not the server. If you already have a server with so much CPU, so much memory, you just need to deploy the new application as a container, or existing one as a, you can scale. Containerized deployments are fast. Understand what I'm trying to say? Understand, guys, what is fast means? You no need to create a completely new server, and if you already have a server with some CPU and memory, and you can quickly release. The one more thing here, when we are working with the Docker, you are going to build a package also, guys. You are going to build a package when you are working with containers. The way we created an application package, you are going to build a package called a container image. Here you are going to build a one more package that is called as a container image or a Docker image. So we are going to build a one more package now. If you are working with the Docker, you are going to build a package called a Docker image or a container image. So this is one more package with the required softwares and configurations, plus your application and its dependencies, everything. So this is one more package you are going to build now as part of your continuous integration. The way you guys created an application package, later you have installed softwares and configurations deployed. But now, when we are using Docker, we are going to build a one more package, another type of package, that is called as a Docker image. You are going to build this type of package. With the help of Docker, you will build a package. This is called as a Docker image. This is called as a Docker image. That image is a package. This is called as a Docker image or a container image. You are going to build a package using Docker image. So you are going to use something called Docker file. Don't worry, I will explain how to write a Docker file, how to build an image. For now, understand the concepts, fundamentals, basics is very very important. As I already said so many times, before you are going to learn any new tool, any new technology, you have to understand the purpose of that tool. For what purpose you are going to use that tool? You guys used Jenkins, you guys used GitHub, you guys used Maven, you guys used Nexus. You have to understand the purpose of that tool. What is the use of that tool, what problems it is trying to solve. Once you understand the purpose, in what use cases or scenarios I can use, for what purpose I am using, you can use in any project. Here, Docker is a containerization software. Docker is a containerization software. Using Docker, you can build packages. Using Docker, you can build a packages called images with the required softwares, configurations, environment with your application. This is called as a container image, Docker image. Guys, machine images is different. Here there is no OS. In this package, we are not bundling the OS. Understand? In this Docker images, there is no OS. You are not packaging any OS. You are just packaging, you are creating a package with the only required softwares, configurations and environment, and required application code. So you can build these type of packages using containerization software. With the help of Docker file, using Docker, you can build a package, and these packages you can store. These packages also you can store in the artifactory. The way you guys are pushing, the way you guys are pushing your application package like a jar, Wares, you can store these type of packages into the artifactories also, like Nexus, JFrog, each, like this. And wherever you wanted to deploy that application as a container, right, you no need to install required softwares here. Suppose I wanted to release this application in your system. You no need to install application related softwares configurations like that. You just pull this package. You just pull this package from that artifactory. You download that image. Image is like a package with required softwares and configurations. You just download this package here and create a container from that image is basically a package. Container is a runtime instance or a runtime process of that image. So container is a runtime instance or a runtime process of that image. So this is very fast. So because you are going to build a package, like this with required softwares and configuration. Wherever you wanted to deploy, you just pull that package and deploy, so that everything will be there up and running. And suppose there is a so much load, so much traffic from the same package. Using this same image, you created two replicas, one container, another container from same image, so that scaling and deploying like that. Containers are fast. Containers deployments are very fast. Understand what I'm trying to say? Containers are lightweight. Containerized deployments are very fast because containers contains everything whatever is required. And you can avoid configuration management tools also, because you no need to use configuration management tools for doing a application related configurations, because you are going to build a package like this only. You are going to build a package with your application code as well as required softwares, configurations, everything. This package you are going to store in repositories, artifactories. Wherever you wanted to deploy, download that package and deploy a container. So here the only required softwares for working with that containers is Docker, containerization software like Docker. So you only required software in this system is Docker. Using Docker, you can build these type of packages. You can move these type of packages to the repositories, and wherever you need, again you can download and deploy. And again, you can avoid environment inconsistencies also, guys. Suppose you have to deploy this in a production server. So here again, this is your production system. This can be a virtual machine or a physical machine. Here you will have a OS, some OS. You will have a OS, and here the only required software is Docker, that containerization software like Docker. Here also you just pull the package. That package itself has everything required softwares, required configurations, everything we have, whatever is required. You pull that package here and deploy that as a container is like a runtime instance of your image. So if that application works in one environment, definitely that application works in any other environment, because there is no different versions, right? Same software, same configurations. Suppose if this application, the application deployed as a container working fine in one environment like dev, that is definitely going to work in another environment like prod also, because you are using a same package that with required softwares, configurations, and everything. So this is how you are going to use a containerized deployment, containers. So this Docker is a containerization software. This Docker is a containerization software. Using Docker, we are bringing isolation to the another level, OS level, software level. So from 2013, the concept of containerization came into the picture. From 2013, this concept of containerization came into the picture. So Docker is a containerization software. But don't think Docker is the only containerization software. Like Docker, there are so many. Rocket is there, Podman is there, like that. But Docker is most popular and widely used containerization software. Using Docker, you can run any other softwares also. You can using Docker, you can run Jenkins also as a container. Using Docker, you can run database softwares also as a container. Using Docker, you can run Nexus also as a container. Using Docker, you can run SonarQube also as a container. Using Docker, you can run your web server like Nginx, HTTPD also as a container. Using Docker, you can run Tomcat, your application as a container. And using Docker, you can run cache, like Reddy applications also as a container. Using Docker, you can run Kafka. Like any piece of software, any piece of code, you can run as a container. Docker is not replacing any other software. Docker is its own category. So Docker is a containerization tool. Docker is a containerization software. Using Docker, we can build, we can ship, we can run any software or any process as a containers. So now the difference between virtualization and containerization here. So as I already said, this is containerized deployment. This can be your physical machine or a virtual machine, right? This is your hardware. This can be a physical machine, virtual machine. You have a OS. Here you have a containerization software. Here you can deploy multiple applications as a containers. So as I already said, containers does not require full OS because it is going to use the host machine. So this container, this application also use this machine kernel. This one also, this one also use. Containers are lightweight. Containers will use the host machine kernel, like that. So sometimes in the interview, they are going to ask the difference between virtualization and containerization, or difference between virtual machines and containers. As I already said, virtual machines are heavyweight because each virtual machine has its own OS. And but here understand, you are not completely moving out of the virtual machines or machines. Your content, your, whenever you are deploying your applications as a containers also, your containers also creating in a machine, but in a same machine you can create multiple containers. Understand, it is not like you don't need any VM, you don't need any virtual machine, or you don't need any physical machine. It is not like that. Still you are using machines only, but in within that machine, within that server, you are running multiple softwares as a containers. So instead of each application, instead of creating separate machines for running each application, within a same machine you can run multiple applications as a containers. So virtual machines are heavyweight, virtual machines are slow. As I already said, the difference between virtualization and containerization also in the asked in the interview. Virtual machines are heavyweight, containers are lightweight. So here each virtual machine has its own OS, but here all the containers is going to use that host machine OS on whatever machine you deployed your applications as a containers. And here virtualization or a virtual machine, they are doing a hardware level isolation. Here software level isolation. We are bringing isolation one more level above. Virtual machines are slow. Virtualized deployments are slow. Virtual machines will take some time. Containers are very fast, and virtual machines will take so much CPU, so much memory. Containers are going to take less CPU, less memory. Here limited performance, because each virtual machine has its own OS. Whatever is available after OS only you can use. But here native performance, right? Containers are going to use again, containers will be using CPU and memory from that system, but it can share how much is required. It can use a remaining CPU and memory can be used by other containers. And here fully isolated virtual machines are fully isolated, so it here it is more secure. But here within the OS you are doing an isolation. Here it is a little less secure, but you can secure your applications deployed also as a containers using some best practices. So we will discuss about how to secure our applications deployed as a containers also by using some best practices. We will discuss also. And understand virtual machines and containers difference. Virtual machines are very huge in size. I am comparing with these factors like a size, startup, integration. So virtual machines are very huge in size, like elephant, because it takes so some time. It takes so much CPU, so much memory, like that. Containers are lightweight. Containers are very lightweight because containers will not have OS. And virtual machines are slow. Virtual machine, I mean to say, virtualized deployments are slow. You have to create a VM, then boot the OS, then install softwares and configurations, then deploy the application. So slow. But containers are very fast, like cheetah. because you are already having a package with everything like required softwares and configuration. You just pull that package and apply so that your application will be up and running. So containerized deployments are very fast, virtualized deployments are slow. And integration is very smooth in containerized deployments or containers. Here it is little difficult. But I have compared the virtual machines or containers with these factors like a size, startup, integration. But don't say virtual machines are elephant. Virtual machine is elephant. Container is like a rat. Don't say virtual machine is tortoise. Containers are cheetah. This is with the factor of size, speed, and integration. So definitely this is very very important. So is everyone clear? What is physical deployment or a traditional deployment? How we used to do the deployments in the early days of IT, and later what is virtualized deployment and virtual machines? How we used to build and deploy in virtual machines. Now the concept of containers. Containers is everywhere now. From 2013 itself the concept of containerization came. Everywhere there is a any application or any software nowadays you take that is being built and released as a containers only. That is why Docker is most popular. But again, if you are using only containerization also, there is a problem. Let's say if something goes wrong with this container, let's say you are deploying your applications as a container. Let's say something goes wrong with this container will not be recreated or restarted automatically. Suppose something goes wrong with this system itself, all the containers running in the system will not work again, and it is not going to recreate or reschedule in another system. So this is where you are going to use containerization softwares along with one more software, container management software. So instead of we create the containers and manage the containers, we are going to request management tools, container orchestration tools. So that container orchestration tools will create and manage the containers. The container orchestration is different, containerization is different. So Docker is a containerization tool, but in order to manage those containers we are going to use some other tools. Example, Docker Swarm or a Kubernetes. So first we'll try to understand containerization tools. Later we'll try to understand container orchestration tools. Without understanding containerization, if I directly explain container orchestration also, you may not able to understand. And again, without explaining today's session, if I directly say go and install Docker like that, so many I can do this way. Create one server, install Docker, execute some command, container will be created. But you don't know what is container, why we are doing this like that. So the fundamentals has to be strong, guys. The basics should be strong. Basics only important. The ground rules is important. The basics are a concepts, that fundamentals you have to be very strong. These advanced concepts are nothing. So that's why I focus more before I teach any new technology or any new tool. My first focus is on the fundamentals, basics, why we are going to use that tool, what challenges or problems it is trying to solve. So first if you understand why, then how becomes easy. But more people focus on how to create a container, by hearting the commands. People by heart the commands, how to create a container, how to build the image. But you don't know first of all why container, what problems it is trying to solve, why we are running behind containers. So commands and concepts will be more clear if you know the basics, guys. I hope today's session is giving a complete idea why people are moving towards the containers, why people are building and releasing applications as the containers, and why people are using that container orchestrations also. Like why you see so many times buzzwords wherever you go, people say Docker, Kubernetes, Docker, Kubernetes. Why Docker? Why Kubernetes? I hope you are getting a understanding. So Docker is a containerization software. Using Docker, you can build, you can ship, you can run any software or any application as a container. So I hope you guys are clear what is containerization, what is virtualization.